Hello, my dear student. Welcome all of you to my online physics class. Hope all of you are well by the grace of Almighty. We are starting a new chapter, chapter 8. The name of this chapter is Reflection of Light. Okay. Today we will discuss on some topic, most important topic for studying spherical mirrors. Okay, the first topics is spherical mirror, and second topics some definition of a spherical mirror. These definitions helps you to study the spherical mirror very well. Okay, and our third topic is relation between focal length and radius of curvature, f equal to r by 2. This relation is very important for exam. Sometimes it will come as comprehension based question, or sometimes as a question for question number C. Okay, so today's topics is very important for studying mirrors, especially spherical mirror. Okay, so let's boys discuss this topic step by step. Our first topic is a spherical mirror. Okay, in our previous class we have learned about plane mirror, but now today's topic is a spherical mirror. So first question is, what is a spherical mirror? Okay, when we use a portion of hollow sphere and coating its surface with a silver or aluminum layer, then this type of mirror is called a spherical mirror. Okay, I am repeat it again. When a portion of hollow sphere, cutting off hollow sphere and coating its surface with a silver or aluminum coating, then this type of mirror is called a spherical mirror. Okay, we have two type of spherical mirrors. We have two type of spherical mirror. Okay, so one is concave mirror, and number two is convex mirror. Suppose this is a hollow sphere. Okay, if we get this part for our mirror, then it is called a spherical mirror. But if the lower surface is coated with silver or aluminum, upper surface of this portion is coated with silver or aluminum, then this type of mirror is called concave mirror. So concave mirror is looking like that. Okay, this is a concave mirror. Again, suppose this is a hollow sphere. Okay, this is a hollow sphere and we get this portion for our mirror. If we coated the lower portion of this portion, lower portion is coated by silver or aluminum, then this type of lens is called convex mirror. Okay, so this is our concave mirror and this is our convex mirror. Okay, the name of this concave mirror is called converging mirror and this convex mirror is called diverging mirror. Okay, so this is our concave mirror and this is our convex mirror. Okay, so this is our first part. Here we already have discussed a spherical mirror. In our next topic we will try to discuss some important definition from this spherical mirror. Okay, so let's see some important definitions. Now our topic is some important definition of spherical mirror, and the number one definition is center of curvature. So what is center of curvature? The point in the center of the sphere from which mirror was sliced is known as the center of curvature. It is denoted by C. Okay, so in our previous topics we said that a spherical mirror comes from a hollow sphere. So suppose this is our hollow sphere and we using this portion as a mirror. Okay, suppose we get concave mirror. Okay, concave mirror. So this mirror is a part of this sphere. So the center of this sphere is called center of curvature. Okay, so I'm repeat the definition again. The point in the center of the sphere from which mirror was sliced is known as the center of curvature. Okay, so it is denoted by C. So this point C is our center of curvature. Okay, our next definition is radius of curvature. Okay, the distance from the vertex to the center of curvature is known as the radius of curvature. Okay, the distance from the vertex to the center of curvature is known as the radius of curvature. The radius of curvature is denoted by a small r. In simply, for a spherical mirror, we used a hollow sphere. Okay, so here the center of this sphere is called our center of curvature, and the radius of this sphere, any radius of this sphere is called our radius of curvature. Okay, the any radius of this sphere is called our radius of curvature. Okay, so I'm repeat the definition again. The radius of curvature. What is called radius of curvature? The distance from the vertex to the center of curvature is known as the radius of curvature. It is denoted by small r. Now our next definition is pole of the mirror. Okay, here the definition is the center point of a spherical mirror. This can be a concave mirror or convex mirror. Okay, the center point of a spherical mirror is called pole. Pole is denoted by P. Here you see that the mirror is our concave mirror, and this portion, mainly this portion, is our concave mirror, and the middle point of this portion, or the middle point of this mirror is called the pole of the mirror. Okay, so the center point of a spherical mirror is called pole. Okay, a pole is denoted by P. Our next definition is principal axis of the mirror. Okay, the principal axis of a spherical mirror is a line going through the center of the mirror that is exactly perpendicular to the surface of the mirror. Okay, here you see in the figure that simply the joining line of these 2 points, the 2 point is center of curvature and the pole. The joining line of this 2 point is called principal axis. Here you see that the principal axis is perpendicular to the surface of the mirror. This is the surface of the mirror. This is the surface of the mirror, and the principal axis is perpendicular to the surface of the mirror. Okay, now I am repeat the definition again. What is called principal axis of the mirror? Okay, here the answer is the principal axis of a spherical mirror is a line going through the center of the mirror that is exactly perpendicular to the surface of the mirror. Now our definition is focal point of the mirror. Okay, so the answer is the focal point is the point in space at which light incident toward the mirror and traveling parallel to the principal axis will meet after reflection. Okay, the focal point is denoted by capital F. Okay, here in the figure you see that the point F is called focal point. Okay, here a light ray AB which is parallel to the principal axis, and again two light ray, one light ray AB and another light ray MN. These two light ray are parallel to the principal axis, and these two light ray, the reflection after traveling or after incident the two rays in the mirror, this two ray is reflected. Okay, so here BC is the reflected ray of AB and NO is the reflected ray for MN. Okay, and these two reflected BC and NO. These two reflected ray are meet after reflection meet they meet a point F, which point is in principal axis. Okay, so this point, the meeting point of these two reflected ray is called principal focal point. Okay, the meeting of these two ray at principal axis is called focal point. So our last definition is focal length of the spherical mirror. This is a very important definition. Okay, so the answer is distance between the pole of mirror and focus point of the mirror. This distance, okay, this distance, the pole of a mirror and focus point of the mirror is called focal length of the spherical mirror. Okay, focal length of the spherical mirror is denoted by small f. Here in the figure you see that the P is our pole and the F, capital F, is our focus point. So the distance between them, okay, you see that the distance between them is called our focal length and it is denoted by small f. Okay, so these are the very important definition, and these definitions can help us to study the image of the spherical mirror. Okay, so now in our next topics we will hear the focal length is f and the radius of curvature. This distance is called radius of curvature. Okay, so this distance, the pole and the distance between pole and center of curvature is called our radius of curvature. Okay, and denoted by r. So we have a relation between f and r. We have a relation between f and r. The relation is f equal to r by 2. Okay, the relation is f equal to r by 2. Now we will try to prove this relation. In our next topic, we will discuss the relation between focal length and radius of curvature. Okay, according to the figure, this length, all the length for mirror, all the length we will measure from the pole of the mirror. Okay, okay. Suppose focal length we will measure from pole of the mirror. Suppose radius of curvature we will measure the pole of the mirror. Okay, so here OX, according to our discussion, here OX is R and OF or OF equal to Fx equal to F. Okay, acha. Suppose OX equal to R, this is okay. Now two parallel rays parallel with the principal axis. Okay, principal axis of spherical mirror come from A and B. Two parallel ray is which is parallel to the principal axis is come from A and B, okay, respectively. The first ray has come to point X. The first ray has come to point X, and the second one has come to point Y. The first ray has come to point X and the second ray has come to point Y. The ray coming to point X will be reflected. This incident ray will reflected back to the way it has come. Okay, and let us extended this ray. Let us extended this ray to the center of the sphere O. So we can write OX equal to R. According to our definitions here, OX is equal to R, equal to radius of curvature or radius of the sphere. Okay. Now the ray coming from B point will B to point Y will create an angle of incident. Create an angle of incident angle. Here theta I is the incident angle, and this incident angle will create with perpendicular ON. Okay, the incident ray BY will create an incident angle theta I with the perpendicular line ON. Okay, now the angle of reflection of the ray BY, the angle of the reflection of the ray BY theta R. Okay, theta R, and it will be reflected towards YP. Okay, it will reflected towards YP. If we extended PY, it would intersect the principal axis at point F. Okay, here FO equal to FY, because this angle and this angle is equal. This angle is equal this angle, and this angle is equal this angle. And according to the laws of reflection, we know that the angle of reflection and the angle of reflection and the angle of incidence is equal to each other. So these two angles are equal. So this this line is equal to this line. So FO equal to FY. Okay. Now here we say that FOY equal to angle BYN equal to theta I, and angle OYF equal to angle NYP equal to theta R. Okay, and so we can write angle FOY. We can write angle FOY equal to angle OYF. Okay, so FY equal to Fx. Okay, so we can write Fy equal to Fx, because when xy is small compared to radius r. Okay, fy equal to fx when fy equal to fx when xy is small compared to the radius. Okay, so then we can write here fo equal to fy, fo equal to fy, and fy equal to fx. So we can write fo equal to fx. Okay, so this portion and this portion is equal, so we can write fo equal to fx equal to fy equal to f, and we can write r by 2, or we can write ox by 2 equal to r by 2. Okay, so from this discussion we can write is f equal to r by 2. From this discussion we can say that f equal to r by 2. So this is the relation between focal length and radius, so the radius of curvature. So the relation is f equal to r by 2, f equal to r by 2. Okay, boys, this is all from today. In our next class we will try to discuss the red diagram for concave mirror. This will be one of the most important class. Okay, so until then, thank you, boys.